In this video, let us see k-fold cross validation. So in k-fold cross validation, initially we are going to declare two C of bracket. So two vectors, so which are indicating TPR and FPR, and they are true positive rate and false positive rate. So I am doing folds equals to create folds of. So we need to pass what is the class or the column on which we want to create folds. So I'm passing class, and the k value or the number of folds as 10. So for doing this create folds and lapply, we have already imported and loaded necessary libraries to the workspace. So I have given folds here and function of x. So it's simply like it will go through each of the time. So when k-fold cross validation is occurring, in the first time 9 folds are used for training. So first fold is left out for testing. So 2 through the 10 are used for training and first fold used for testing. In the second iteration, second fold is left out and 1 and 3 through the 10th one are used for training and second is used for testing. So by this means we will not leave out any data point without training and testing. So every data point is trained once and also tested once, at least once. So what I am doing is, so for each iteration, so training fold is, so x will return some indices after 10 each of the 10 folds. So in first fold, this will have the testing fold indices, x will have the testing fold indices, so that is written. So other than the testing fold indices, the remaining are taken into training fold and testing fold indices. So in that particular iteration, what are the testing fold indices? They are present in x, so they are taken into test fold. So after that, as we have done previously, we will just apply the rpart library and do the similar thing. We are predicting on target column class and we are using everything present in the data set, all the remaining columns, and here the data is training fold. So we're using in the previous we used training data set, here using training fold. So method equals to class, parameter equals to list of split equals to information. So on the similar words, we can take the class column into test fold out. After doing this, I am trying to predict on the test data similar to before. So ypred equals to test model underscore k-fold. So we are using this model which is built here for testing on our test data or predicting on our test data. So predict of test fold data comma type equals to class. After that, I am constructing a confusion matrix. EM indicate confusion matrix, and I am constructing a table where we need to pass two things, that is test fold of comma nothing comma 10. So it will give us the 10th column of the test data, that is a test fold data, and ypred indicate the predicted data. So true is passed here and predicted is passed here. When we do this, so we'll get a table and I'll show it now. So when we are doing accuracy, we are actually going into this CM and we'll get a 2 by 2 matrix in a CM, and when it is 0 and actually it is 0 and predicted is 0, it will be in 1 position. And similar words, we can explain how this confusion matrix formula is written. So accuracy means really what is predicted is true, and by total whatever are the entries. So only the diagonal entries in the confusion matrix indicate the true outputs, which are also predicted as correctly, and the total indicate the whole entries. So I will append that into accuracy. So initially I have declared accuracy without nothing, so I'm appending ACC into that vector. So on the similar scale I am also calculating TPR and FPR, and after that I am using cbind to combine all the three into one variable and passing or returning it as a result. So I'll just run this. So after this I'm just, so let me run it again. So I have not run it, so it's, we need to run these things: TPR, FPR, accuracy, holes, and save. Now if we do it, then we'll get three vectors as a matrix. So accuracy, TPR, and FPR, and at each fold what is the accuracy, what is the TPR, and what is the FPR. So to get the average accuracy, I am accessing the each of the values in each fold. So b dollar fold of one return the accuracy. So on the similar scale, fold 2, fold 3, and so on, fold 10, I'm taking the accuracies into one vector, and I'm printing it to the output. And after that I am calculating average accuracy by using the inbuilt function mean of accuracies. So let me print out, I got a 95% accuracy. So it's the average accuracy of all the 10 folds. So let me continue in the next video.